my name is Skylar Rogers, and today I will be talking to you about electric motors. In this presentation, I will go over the main components that an electric motor consists of, along with their respective operations. We will go over the two main variations of the electric motor, and the many applications they have. I guess what you could call the main component of every electric motor is the stator. The stator, while being a housing unit for the armature, is also a stationary magnet, hence the name stator. On the right, up here, you can see these big blocks labeled north and south. They are called permanent magnets. They generate a magnetic field through which a current-carrying coil will travel perpendicularly. On the left, down here, we see an electromagnet as the stator. The electromagnetic field of the electromagnet can be controlled easily, and that makes them more preferable over permanent magnets. Next, we have the armature and rotor. Everything you see in this picture, minus the stator and these brush arms here on the left and on the right, make up the armature. In the armature, furthermore, we have loops or coils running perpendicularly, carrying current through the magnetic field. These coils are separated by laminated iron-based discs that enhance magnetic flux. These coils are attached to the commutator, which supplies them with current. The current, the commutator, is supplied via the brushes. Here in the bottom left, we see a cross-section view of the coils wound around the laminated discs and then attached to a power supply. Lorentz law states that a current through a wire will produce an electromagnetic field. We intensify this by wrapping these wires into coils, as you see up here in the left. These small field lines indicate the electromagnetic field of the wire on itself, and these bigger ones equal the electromagnetic field of the coiled wires together. Remember the left-hand rule we learned in Physics 2? We can use this to find the forces acting on the rotor due to the stator, which causes rotation. Hence, you have mechanical work from electrical energy. To get the electromagnetic fields to interact, you must supply a current to a rotating conductor. We do this using the commutator and brushes. In this zoomed view down here on the bottom right, we see the commutator broken into sections. One section per coil. Up here, top, we see that we have two sections per one loop. One for negative side and one for the positive side. The commutator will rotate with the rotor, but keep in contact with the brushes. These brushes wear over time and require maintenance often. This is a downside of the direct voltage motor, as alternating do not need brushes. Here is a DC motor. We have the rotor and the armature. Armature is containing those coils running perpendicular to the magnetic field created by the stator right here. The coils are fed electricity through the commutator right here, which are in constant contact with the brushes. AC motors really only consist of two main parts, the rotor and the stator. With AC motors, an electromagnet will always be used. In these three photos, we see a three-phase current being ran. In the bottom left of each picture, you can see each sine wave. These interacting electrical forces cause a rotating magnetic field. These sine waves down here. When current is supplied to the rotor, shown here in this squirrel cage rotor, we see the current transversing the conductive bars and producing its own magnetic field. The interacting fields, again, translate electrical energy into mechanical power. Both motors have their own respective use. DC motors lean more towards household items, electronics like cooling fans on your computer, appliances like blenders, washing machines, fridges, power tools like drills. This is due to their tendency to have permanent magnets, which make them smaller and more portable as they are lighter than the alternative electromagnets. Alternating current motors applications lean more towards the industrial or commercial side. Moving any real load in industry, whether that be people or cargo, on elevators, escalators, conveyor belts, whatever, will more than likely be in alternating current motors that are also used in cooling fans in giant warehouses and in many, many machines. So, as we said at the beginning of this presentation, we went over the multiple components of an electric motor, that being the stator, the rotor slash armature, the commutator, and the brushes. And then we went over the two variations and all their multiple applications.